Yes, sir.
Yes.
Okay, so let's get started. Hmm. I hope the slide is visible, right?
Yes, sir.
Yes, sir.
So we have discussed about polymorphic hierarchies. We have specifically seen how to create polymorphic hierarchies with possibly an abstract base class in the at the root, and there could be multiple other abstract base classes on the hierarchy as well. And the abstract base class is characterized by one or more pure virtual functions, which are just provided in terms of signature, but we may not know how to implement them. So we tell the compiler that we are not implementing them. So abstract base classes mean that we cannot construct objects of those classes. And we have seen that in a polymorphic hierarchy, the root class must provide a virtual destructor so that slicing of objects do not happen when objects are destructed. Right? So we have seen all of those features, sample examples, and what I have provided here are some exercise of polymorphic hierarchy. This is a hierarchy of three classes. I've given some example to show the initialization and what will be the effect of actually writing this kind of code. I will not run through that in the class. This is more for your practice. We will today move on to actually take up a small example. We are on slide 6, module 29. We will discuss a small example to show a real life example, rather, to show how you should actually design in a object oriented way to get a very efficient code structure. So the process that we'll follow is here is a statement of the problem, very brief statement of the problem, because we are not looking into actually writing the business logic at every stage, which are finally procedural codes or maybe some object based codes which you can write, but we are more interested in doing a good design. The process that I'll illustrate is a very important principle of software development as practiced in software engineering, is a kind of a process of you can say iterative refinement. So given the problem statement, I will first come up with a design which is in kind of a C language, which you could have done after having learned your PDS course, and could have provided a solution that solves the problem, obviously. Then we'll show, then we'll try to observe what are the shortcomings of that design. Why do you need to move on to object based design? And then we will discuss a solution using non-polymorphic hierarchy of classes, and give the solution of the same problem, removing some of the shortcomings that the C model or the C coding had. And again, we will observe that there are shortcomings in terms of what we have done and in terms of what might possibly happen for extension, and refine that with polymorphic hierarchy now, and show how the design becomes more uh, flexible, how it in the process, how it improves the reuse of the code, and overall becomes less prone to errors. So I mean, discussing this example and the process is the main consideration today. So this is kind of an exercise that every software engineer has to go through several times in her work life, working on different problems. That you have a statement and you come up with a design, and then you keep on refining that design till you come to a solution which is really good and acceptable. So the solution, the problem that we are taking is a simple problem of processing salary for staff of an organization. So what we assume is that there is an organization where the engineering division has engineers and managers. Just a simple two kinds of employees, engineers and managers. Every engineer reports to some manager. Every engineer will report to some manager. And every manager, besides being a manager, can also work like an engineer. Manager can do extra stuff also, but if required, she can work like an engineer. Now, the salary processing logic for engineers and managers are different because they will have different salary heads. Managers may have more of performance linked components, bonus, and so on, which engineers may not have. We are not concerned with what that logic is. That logic could be anything. What we are focusing on the fact that the salary processing for engineers and the salary processing for managers are different. This is the current state. In future, the organization may add directors to the team as well. If directors are there, then every manager will report to some director. Like the engineers are reporting to managers, the managers will in turn report to some director. And like every manager can also work like an engineer, every director could also work like a manager, and therefore could also work like an engineer. So that's a basic property they have. Certainly the salary processing logic for directors will be different. Possibly directors will have employee stock options and so on, right? So again, we are not concerned with what that logic is, but it's different. Further, in future, the organization may open other divisions. This whole thing was up for an engineering division. Say it may open other divisions like sales division to expand its workforce. This is the conceptual problem that we have at hand. And as a software designer, our task is to make a suitable, reliable, extensible design. So this is the problem statement. I hope it's clear to all of you. So let's say if we are working for a C solution, which will be using function switch, as we have seen, and we are working for engineers and managers. So some of the basic questions that we'll have to answer in this design before we can actually get to the code is, how do we represent engineers and managers? These are entities which will have to be represented. So we will represent them as structs in C because they will have multiple properties. We'll put them in a struct. Naturally, how do we initialize those structure objects? So we'll assume that there are some initialization functions for these objects, for these structures. Something we saw in case of the stack example, the initial C type of stack example when we did. Now we will need a collection of mixed objects because some of the staff are engineers and some of the staffs are managers. So how do we put that in a collection? Naturally, they are of different struct type. So we will have a union. And then we will have an array of union objects to represent the whole collection of stuff. So it's an array of union objects where each element is either a structure representing an engineer or a structure representing a manager. Right? This is the best that we can do to make the whole collection work. Now, how do we model variations in salary processing? Naturally, for every type of structure, we'll have a structure specific salary processing function. Right? So then finally, how do we invoke the correct algorithm for the correct employee type? We'll have to do some kind of a function switch or function pointers. So based on the requirements of the problem and the paradigm of solution is C programming language, where we have structure, where we have functions, where we have union, where we have arrays, where we have function pointers. So mapping to them, this is kind of an outline of how you can analyze and try to work towards the solution. These are very important parts of the software design. This is important parts of the engineering that you do. We will, after we complete discussions on object orientation and C++, we will also present this whole process in a more formal way. But you can see that you have started with a basic specification of the problem, working towards the design, and in that process, we had to first analyze the problem. And the analysis tells us that these are some of the questions that will obviously come from the specification. And these are the possible answers that we are giving ourselves so that we can go ahead and do the design. Right? So I'll go to the next slide, which is slide 8 in module 29. So I define struct engineer to represent an engineer entity and struct manager to represent a manager entity. We do a type def alias to call it engineer and manager respectively. In this struct, we are just making a minimal design right now for understanding. So we just assume that there is, for engineer, there is only one component, that is the name of the engineer. For manager, also there will be a name, but the manager also has several engineers reporting to the manager. So I need to know who are the engineers who report to the manager. So I have an array of engineer pointers called reports. I'm arbitrarily assume that it is 10. Maximum is 10. So maximum 10 engineers can report to a manager. So I keep this information, and these are the basic two entities. Now, I need to have initialization of every object. So when I have initialization of every object, for initializing engineer, I construct a function init engineer, which will initialize. So what it has to know? It has to know the name of the engineer. So it takes the name of the engineer, and then it dynamically creates an engineer object. It does a malloc for the size of engineer, casts it to the engineer pointer type, and it gets that. And once that has been done, the allocation has been done. Now it has to copy the given name into the particular name component, name underscore component of the engineer objects. So it does e pointer name underscore, it does a string dup of name, and then the engineer object is ready, it returns it. So this is the initialization. Similarly, the initialization for manager is done by init manager. Right now, we are not dealing with the reporting information in this solution. We can add that later on. Next, what we need is the processing algorithm, the processing functions. So for engineers, we design a function process salary engineer, which takes an engineer pointer and does the process salary. That logic could be anything, but we are just abstracting it by doing a print message for process salary for engineers. There could be, all detailed logic of how to process salary of an engineer. Similarly, I have another function, process salary for manager, to process the salary of the manager. So these are my basic design components. Now I have to represent these instances of these engineer structures and manager structures in terms of one common entity, so that I can make a collection of those entire staff. So I create a union. So here in the last, I create a union of an engineer pointer and a manager pointer, which means that at an instance of this union, either I have a pointer, but that pointer is either an engineer pointer or a manager pointer, right? So that brings me to the question of how do I remember whether it's an engineer pointer or a manager pointer? So I add another field to the struct staff. I call it, this is called the tag type usually. So I want to tag whether it's an engineer or a manager. And I do that by an enumerated E type, which I have defined on top. So enum E type has two constants, ER and MGR, so that it can take any of these values. And naturally, what I mean, I can put a comment here also, that if the tag type is ER, then in the union, it means that I have an engineer pointer. If it is MGR, it means I have a manager pointer. Right? So this is my entire data representation design that has come off. Now, how will the application? So this is my design, which will remain the same. And now my application, which will have to create engineers and managers and process their salary. So I go to the next slide, slide 9 in module 29. So I create an array of staff. So the array of staff, say maximum, I've assumed 10 staff, all staff. And now I could take all these values through input, but that's not the part of the design that we are highlighting on right now. So I've just hard coded them. So say the 0th staff is an engineer. So staff is a union. So it has two components, type. Just let us go back. It has type and it has one of these pointers, right? So I put the type as ER because let's say this 0th engineer, 0th staff is an engineer. And since Rohit is an engineer, so I do a init engineer to construct a engineer object for Rohit that returns an engineer pointer. So I put it to PE. The next staff at 1, say, is a manager. Kamala is a manager. So I create a manager object based on Kamala and put that pointer to PM. In this way, I create Rajiv as a manager, Kavita as an engineer, Shambhu as an engineer, and so on. So 5 staffs I have created. Now, say if this is the current situation of the organization, then I want to process their salary. So what I'll have to do, I'll have to go from 0 to 5. I've hard coded all of that. Those are finer design issues that we can come to. That is what is called the low level design we'll have. But I'm just interested to illustrate the structure of this whole design process. So how do I process the ith staff, all staff I? I need to know whether the staff is an engineer or a manager. So I will access the type field and call it T. Now, if the type field is ER, then I know that the staff is an engineer. So I have to call the process salary for engineer. So I'll call the process salary engineer function with the employee, with the engineer pointer PE. So I call it with all staff I dot PE. In the union, I'm accessing the PE field because the tag is engineer. If the tag is not engineer, then I check if the tag is manager. If the tag is manager, then I do process salary manager function, a different process salary, with the PM pointer, because now the staff is a manager. So the pointer to that is kept in the PM field. Otherwise, which should not happen, but otherwise, if I see that, well, it is neither ER nor MGR, then it is an invalid staff type. So that's kind of an error. So I go over on this for loop and I will do the process salary for either engineer or manager. And naturally, my 0th was Rohit. who was an engineer. So it prints process salary for engineer. These are actually processing salary. We are just modeling by printing a message. Kamala process salary for manager because Kamala is a manager. Rajiv process salary for manager, and so on. So I have a solution which is in terms of my features available in C programming language, and what the mechanism that I've used is a function switch. Here I've written it as if else. I could write it as a switch statement also. I could say that switch all stuff I dot type case ER colon process salary engineer, case MGR colon process salary manager, default colon printf. This I could have write it. So, but this basically is a switch. Right? So this is my first solution. So let me now think that what if we get to the next part of the problem, that in future it might have directors in the organization. Right? So I'm on slide 10 of module 29. Again, I go through the same considerations and I have the same, on the analysis, I have the same answers, because all that I have done is just I have added a director type. Nothing else in the design has changed. The problem specification has changed. So the design remains to be, analysis remains to be the same. Kindly mute yourself. Somebody has unmuted. Kindly mute yourself. Kindly mute. Now, with this, I change the code in slide 11, module 29. The engineer part of the code remains same. Manager part of the code remains same. Now I add a struct type director with the name and a array of pointers to managers to maintain all managers who report to this director. Then I similarly have a init director initialization function to create a director object. I have a process salary for director. And now since I have added a third type of staff, so in the enum type, I add another enum constant dir. In my union, I add another pointer type, another pointer PD, which points to a director. Right? So this is how the design gets extended, with the director also becoming a valid staff. On slide 12 now, I have again the instantiation done in the same way. The addition is Ranjana is a director of the organization now. So her type is set at dir, and once the object for Ranjana is created, the pointer is set to the PD of the union. Naturally, type switch will now have to extend with another case, which is earlier I had T equal to ER, T equal to MGR. Now I have T equal to director, the processing for the director, and the code works. Right? So this is this is how we could design it for engineer and manager, and can extend it for director using the C modeling paradigm. So let us do a self-evaluation of how are we doing in terms of this design. Slide 13, module 29. So let us look at the pros and the cons, the advantages. Obviously, the first advantage is the most important one, that the solution exists. That's the first thing, first outcome of a design that you need is it solves the problem. If it does not solve the problem, it is not a design. So it solves the problem. The second we see is the code is well structured. It has a pattern. Like for every employee type, I have a type def, I have a init function, I have a process salary by name function, and so on. So it has a kind of a pattern. So it is kind of repeatable in that way. So that's a good structure. It's not a haphazard code. But it has a lot of disadvantages. The employee data has scope for better organization. The employee data is not well organized. First is there is no encapsulation. So we are using struct, so everything is open. Any application programmer by choice, intentionally or inadvertently, could change any employee data without it being noticed. There are duplication of fields across employee types. So the same, cat star name is written everywhere. So maybe the next person who adds the next employee type may not note that the name was cat star in earlier designs, earlier classes, earlier structures, and might use string type for a name. So there is possibility of mix up there. Employee objects are created and initialized dynamically through the init function. So the shortcoming of the design is lot of objects are created dynamically, lot of memory is allocated, but they are not released. So also you'll have to remember to release all of those that have been initialized, right? So the data organization has a lot of scope for improvement. But more importantly, the types of objects are being managed explicitly by E-type. So it is difficult to extend the design. If I add a new type of employee, like we did for director, these are the changes that we need to do, and they're significant. We add a new type to the enum type. We have to remember that. We add a new pointer field in the union struct stuff. We have to add that corresponding pointer field. And we have to make change also in the application. These first two are changes in the library design, which is your basic design of representation. And the next one, there's a typo. It should be if else, not it else, if else. So in the application where we are processing all the staff salaries, we had to add another if condition or another switch for the new type. So every time I change, the whole application has to be changed and recompiled based on that, and changes may happen at multiple places. It's in a way error prone. The developer has to decide to call the right processing function for every type. So if it is ER, then salary processing for engineer has to be called. If it is MGR, salary processing for manager has to be called. Think about an organization, say Hindustan Petroleum, where there are about 250 types of employees. So you can think that how big this switch gets, how many different E types you will have, and how many different names you will have, and it really can get enormously messy. So based on this analysis, which is in software engineering terms is called design refinement. So we have a design which meets the two basic requirements, that it solves the problem and it has a well-structured pattern. But we put that again through analysis. We put that through our scanner and come up with a lot of shortcomings on that design. And based on those, we create a new recommendation for the refinement of the design. The recommendation is to use classes for encapsulation on a hierarchy, right? So two things. We should use classes for encapsulation, and we should use hierarchy, because in this whole design, one information we have not used is the manager can work like an engineer, a director can work like a manager, which says that there is obviously a prevalent is a relationship between these staff types. So this is what is the first C-based design. Let me pause for a while before I go ahead and start discussing the refined design. Let me see if there is any question up to this point, which I'm sure this is a solution which maybe you would have taken a little bit of effort to organize it well, but I'm sure all of you have done PDS course extensively, have done well. Only of you could have come up with this solution, right? Even without doing the software engineering course. Okay. So quite evidently there is no question. It is too obvious for you. So let me move on. I'm moving on to the next module, which is module 30. So now we will try to contrast this C solution with a solution which is based on classes using encapsulation and a hierarchy to represent the interrelationship between these classes. So this is the problem statement, the same one. It's just given for completeness. This is the consideration for the earlier design for engineer plus manager. And this is the evaluation of the last design that we have just seen. So now let us look it through the specs of object orientation. So the observation that we make is manager is an engineer, right? So every manager is a specialization. So whatever engineer can do, manager can do additional things. Right? So now the first thing is, again, the same set of questions. The answers will now start getting different. How to represent engineers and managers? Certainly, since there is a relationship, we can represent them using a class hierarchy. To start with a non-polymorphic class hierarchy. How to initialize? Obviously, constructor, destructor, well known. How to have a collection of mixed objects? Since this is a hierarchy now, so I can use the array of base class pointers to represent everything, because as we have known, is any specialized class object, the pointer to any specialized class object could also be treated as a base class object, right? So we could use that property to kind of replace the concept of union that we had earlier. Right? So array of base class pointers. How to model the variations in salary processing algorithm? We can subsume the salary processing functions as member functions in the respective classes, and then finally implement a function switch. Right? So these are the answers to the design analysis, putting the object orientation, encapsulation, and hierarchy principles of object orientation onto the problem specification. Resultant schema of the design. The resultant design, module 30, slide 8. We still have a tag type, E-type, ER, MGR, because we need to know what is that. Now, in the class, what we do is besides the name, we also put this tag type so that we know if it is an engineer class object, then we will have its E-type set to ER. Right? So I have the constructor, which takes the name, and the ER type, E-type, which is ER. Actually, I can actually hard code this also. We may not even have it as a part of the constructor, but we could just hard code this. A type is ER. And there is a way to know this type externally, because I will need to do processing based on this type. So I provide a get type public method, get type method in public, and we have the salary, process salary for the engineers. Similarly, we have the design for the managers, which is specialized from the engineer. We have a private field array of pointers to engineers to keep the reporting information. We are still not using them. And we have the constructor in a similar way, where E-type is MGR. Okay. We have a process salary. We do not provide get type again, because being inherited from engineer, manager will get the same member function inherited here, and that is the same functionality, that is returning the E-type is a functionality that we want. But we override process salary by the same name, of course, to process the salary of the manager. So process Earlier we had to call process salary engineer, process salary manager. Now we have process salary for both. Again, creation of instances. The collection of the staff is an array of base pointers. So I create an array staff of base pointers, that is engineer star, and initialize it with all of this. I mean, this could happen through a big process of acquiring the information on the staff, engineer, or manager and adding it to the array. I'm just trying to kind of create the situation to illustrate the core point. So there are 5 staff initialized. Then I write a iteration on this, iterating over this array. So this gives me the number of elements in the array. And for every element, I first get the type of the object, whether it's an engineer or a manager. If it is an engineer, I call the staff I process salary, because staff I is a pointer of engineer type. And that process salary is what? That process salary function is what I need to invoke. But if it is not ER, if it is MGR, then I have to call the process salary for manager. So what I do a casting of the staff I pointer to manager. Right? I do a forcible casting. Mind you, this is as we had discussed, this is not an advisable solution at all, because we are downcasting the pointer. We are coming from engineer below to manager. We are specializing. We are making that cast forcefully using the C type casting. But we know it is safe because I know that the tag type is manager. So I know it is a manager object. I'm managing that, and I cast that and do the process salary for manager. Now it calls the process salary for manager. Then, of course, for others, I have invalid type. So I have now refined this solution, but still managing the type of the object myself. So given this instance, it runs and gives me the correct output. So I have refined the design from the procedural style to the object-oriented style with encapsulation. Let us move on and add the director. Naturally, nothing changes in terms of these considerations, except the is a relationship, director is a manager. So I come to slide 11, where I have made this addition. I have added dir to the enum type. I have added director class as a specialization of the manager class. I have a reports array of manager pointers in that. I have a process salary again for the director, the same name. And I have created an instance with one director. In terms of the processing logic, I now have another switch, which is where the tag is director. The employee type is director, so that I take the staff I pointer of engineer type, downcast it to director pointer type, and then call the processing function, which calls the processing function of the director. Right? So I can see that the addition of new type, staff type, is possible, and the code runs. So the solutions that we had done in the C paradigm, the procedural paradigm, now we have transferred them to the object-based paradigm, and it is time for design evaluation. So we have now more number of advantages. The data has been encapsulated. Hierarchy factors common data members, for example, the name, the tag type. These we have put only in the base class. We do not need to repeat it in every class. So that factoring has been done. The code has been factored to be made simple. Constructor destructors introduced, so they will manage the lifetime. We have not written destructors, but if we write destructors, we can obviously take care of whatever is the wrapping up required. Structure specific member functions, which structure specific functions, which earlier had to have different names, have now been overridden as member functions with the same name. So that makes that means that I do not need to remember the name of the processing function of every corresponding employee type. The E type has been subsumed in the class. So we have made it a member of the base class, and therefore for every object. So there is no need of the union. We have been able to get rid of that. Naturally, code reuse has been evidenced. So there are quite a few advantages that have occurred based on the design changes, using particularly the encapsulation and a little bit of information about the inheritance hierarchy. But still, there is a crucial disadvantage that remains, that the type of objects are still managed explicitly by E-type. I'm using a hierarchy, but even then, how do I know which object I have got? Whether it's an engineer object, a manager object, or a director object. So I have to explicitly maintain the E-type and do the switch based on that. And so every time I add a new type, I have to add it to the enum, which is kind of not comfortable. But most importantly, the application code need to have a new case to be added. So every time I add a type of employee, my application code has to change. Right? So this is a big disadvantage. And it is error prone because the application programmer has to do a casting to the right type, or rather the application programmer is doing a deliberate downcast, a very risky proposition. And if the application programmer makes a mistake in terms of the tag it is checking and the class pointer type to which it is being downcast, then we will have disastrous effects. So this is my design analysis in the second stage of design refinement. So analysis and design are iterative processes. It's not that in one go you can get the best design. You take the specification, analyze, get a design, evaluate that design, analyze again, get a refined design, again evaluate, do the analysis, and so on. You keep on going like this. So this is the second round we are doing. So now our recommendation is, well, we have done everything, but the hierarchy is non-polymorphic. So let us make it polymorphic hierarchy. So again, I come to the analysis of this refined design. I have the same is a hierarchy. My representation is now a polymorphic class hierarchy. That is my design choice that I'm making. Constructor, destructor, array of base, member function remains same. Instead of function switcher pointer, I will now make use of the virtual functions. So these are the two changes which are consequences of the polymorphic class hierarchy, and let's see how does it impact on the design. So I'm directly showing here the design with engineer, manager, and director. So I have rest of the design same, except that process salary, this member function I have made virtual. So it become a polymorphic function. Then I have overridden it all through in the manager, in the director. Rest of the design is same. I've got rid of the E-type and the management of the E-type. The beauty of this design is, look at the application code. The application code is just one call. All those checks and type management and all that are gone, because I have a pointer of engineer type, which is a base class pointer. And I may be pointing to an employee, an engineer object, or a manager object, or a director object. But since my process salary is a virtual function, it will be dynamically bound. So based on the object type that I have, the corresponding process salary will be called. So for E1, the process salary of engineer will be called For M1, the process salary of manager would be called. For M2, process salary of manager would be called. Finally, for D, process salary of director will be called. This whole code becomes just one call. A huge reduction in the code, and that gives us a huge advantage. This is, of course, the if you actually these are all perfectly running codes. You can just copy paste and try them out for your practice. Evaluation. Let us evaluate it again. So the data is fully encapsulated. Now, polymorphic hierarchy removes the need for explicit type management. That's a big advantage of a polymorphic hierarchy over a non-polymorphic hierarchy. The reason I commented sometime yesterday that it is, if you have a hierarchy, then it should be polymorphic. Non-polymorphic hierarchy has very limited use. The application code has now become independent of the type in the system. Now, if I add a CEO type over the director, so that the director reports to the CEO, and I do the process salary, everything, my application code no more needs to change because I have gotten rid of that switch altogether. So the application code does not even need to be done anything with. So there is high code reuse. The code is short and simple. So this is a basic principle of software engineering, that how do you improve the quality of the code? Increase reuse, one. Second is write as less code as possible. If you write less, you can make less mistake. If you write less, there is less to review. If you write less, there is less to test, right? So keep code always short and simple. So all these are advantages, except the fact that it is difficult to add an employee that is not a part of the hierarchy. The base class of this is an engineer. So you can only add those kind of employees who are some kind of engineer, right? So that remains to be one basic shortcoming after having done this third round of design refinement. So that is our analysis result. So the recommendation is, since we do not know what kind of employees or what kind of divisions might come up in the organization in future, let's add a basic abstraction for employees, right? So let us add a basic abstract class. So this was the hierarchy earlier. Director is a manager, manager is an engineer. This was the hierarchy. Now I add a root class employee, and just to illustrate a different branch, I create a hybrid inheritance for a sales executive who is an employee, but who is not on this ladder of director, manager, engineer, and so on. But engineer certainly is an employee. So this is a polymorphic class hierarchy with abstract base class employee. Nothing else in the design considerations change, except that the virtual functions that I have in employee, which is a virtual concept. I know employee gets a salary, employee works, employee takes leave. These kind of things I may know. But beyond that, I do not know anything concretely about the employee. Also, I do not know what kind of logic should be used to process the salary of an employee. So this virtual function will become a pure one in the employee. Let us work that out. Now we are in the fourth phase of the design refinement. We have from engineer, manager, director, this part of the design remains same. I have added a root class employee with a process salary virtual function, which is pure, because I do not know how to process the salary of an employee in general. I've promoted the string component from engineer to this base class, because every employee must have a name. That's a common property. And I have derived specialized engineer from employee. So this is one part of the hierarchy. Then on the other part, I have now added a sales executive who is also an employee and has a constructor and the process salary, overriding the process salary virtual function for the employee. So as you can see that employee is an abstract based class here and everything else is a concrete class. And I can add any concrete class directly as a child of employee, or I can add a whole hierarchy tree below any node, and this whole design will survive on top of that. So I still have this instantiation where along with employee, manager, director, I have also instantiated two sales executives, Hari and Vishnu. Interestingly, my processing code does not need to change. The application code does not change. So that's a huge, huge advantage. And this is the processing salary for this. Right? So this is how we have in 4 stages refined it and come to a solution which where you might think that all these have been achieved. Data is fully encapsulated, flexible, a polymorphic hierarchy with an abstract base class gives you the complete flexibility to extend the design, maximum code reuse, code is short and simple, and possibly there's no particular disadvantage there. This can still be improved, but I mean, design refinement never stops. This can still be improved, but for now, I will leave that as a thought exercise for you. So if you can think of ways to improve this design in terms of either the library part of the design, which represents the employee data of the organization, or in the application part, in terms of managing this collection, particularly this looks little clumsy that I have to know each and every object and make an array of that, and kind of looks kind of a little clumsy stuff. And then finding out the number of elements or how many employees are there in this kind of an expression, this look clumsy solutions. This still, smells of little bit low level C style programming. So maybe what if we could manage a kind of collection of employees to make sure that every time an employee of any kind gets created, that employee object, which could be an engineer, a manager, a director, or a sales executive, or anything else, automatically gets added to that collection. And then my application code just needs to iterate over that collection for as many employees as are there to process the salary. Could you think of doing that and get rid of this clutter that exists in the application code, right? So I'll leave that to you for an exercise right now. If you can think of some solutions, you can mail me. That will have bonus credit for you if you can mail me a solution or a suggestions for what can be done. Obviously, in the next class on Wednesday, I will discuss that solution and tell you how this can further be improved. So today we have actually taken a deep look into how the problems can be, how a polymorphic hierarchy can really make a nice solution, and how from the specification I can go through a whole series of iterative design refinement and evaluation to get to that solution. So maybe I've shown you the whole process here. The more and more you mature, much of this different stages of refinement, you may not actually need to write the code and do them. Maybe you'll just do it mentally and come up maybe at the 3rd level or the 4th level very directly, quite easily. And that's what we are trying to learn. That's what we are trying to illustrate, that how moving from procedural to object oriented and following the core principles of encapsulation and polymorphism in object oriented design can improve the quality of solution substantially. If there is a question quickly, I can answer. Otherwise, we will close. Any questions? Anybody? No? Oh, I know you all are very smart, so you must have followed everything very well. Okay, thank you then. Thank you very much for your attention. Have a nice day, a good weekend, and we meet again on next Wednesday. And in the meanwhile, you will have your third assignment released by this weekend and start working on that. Bye.